Okay, the recorder is on, and we are going to proceed into this class. This is cisp360. Okay, remember I told you guys that I would actually write the program of the mastermind playing game on Monday, and I did not remember to do it until 8:40 this morning, like about 25 minutes ago. So some people said, someone said, well, since I'm not getting it done, maybe we can postpone the homework assignment. Well, I only said that I didn't get started until 8:40. I did not say that I did not finish it.
Oh my God! So you finished it?
I did finish it.
There we go.
That's why it was a little bit later than usual, because I was, most of the time was spent actually typing it up. That took most of the time. The debugging part took a little bit of time, but not as much time as I thought it would take. Okay, normally I would take more time to do that. So this is the actual program. If you you can only run it. This is just the executable, because I don't want to give you the source code, right? So this is just the executable. You can run it in a Linux 32-bit environment, which is your virtual machine. So you can actually download it if you want to, run it in the virtual machine, and actually see what the program is supposed to do. Yep.
So this program is give us the idea how to write for mm.game.
That is correct. mmauto. mmauto. So let me just save the link first into the temp folder. Is fine. I can run it from any folder. So I go to any command prompt, go to the temp folder, and okay, that's fine. Chmod, let's see, U+RW. Okay. All right. Still complaining about it. There we go. Now we can do anything with it. There we go. So the program, is automatically generating, the patterns. In this case, I'm using all the defaults from mm.h from the first homework assignment. So it will only go from 0 to 5 for each peg, and there are only 4 positions. Okay. So what we'll do is, okay, are you guys ready? Okay. So what we'll do is we'll use this program to play against the other program, which is here. And this time we have to change the number of colors. Code length is 4. Oh man, this one is going to use all 6 colors. I have to find another one that can let me play with only 6 colors, because that's the current setting of my program, and I did not change it to 8. So we'll go ahead and look for mastermind game and see if there's another one that we can find. Okay. Instructions. This one has 8 colors as well. Okay, so I have to find one that has only 6 colors. This is an app. IQ score 0. I think I'm supposed to memorize all images. Oh, forget it. That's not gonna work. Come on. I think that's only. Okay. There's no game that I can use to. Well, we can play against you, okay, or against myself. There we go. All right, let's come up with a pattern that we are hiding from the computer. You guys can come up with it. Try to trip it up, okay? So each position can only go from 0 to 5, just because of the way the constants are defined in m.h. Okay, come up with a pattern.
0, 1, 2.
0, 1. That's too easy.
I found one that's got 6 colors.
Oh, okay.
It's ArchimedesLab.org.
Okay, Archimedes. Okay.
I think we use
Archimedes. And that would be the one. This one?
Yeah.
Okay. So that's 6 colors, and we have to enumerate the colors in the same way. So blue is 0, and then yellow is 5, basically. Okay, so 0 to 5. That's just a help screen. Okay, so I just want to make sure that we configure everything correctly. All right, so we'll pop up. Well, let's see. We'll do this. I'm going to put this on one side. Let me do this. And it doesn't let me scroll. There we go. Because I have to show both screens at the same time. So I'm going to make one screen as small as possible so that we can show both screens. There we go. All right, so this is one screen, and then the other screen I can shrink it at least for the time being. There we go. All right, so now we have both the actual game screen on the right-hand side and my command line program running on the left-hand side. So we're going to play this game. The way we are going to do it is to enumerate all the colors. So the blue is 0. So my initial guess would be all blues. So we pick the blues, and we say 0. Oh, okay, this is blue, blue, blue. There we go. One more. Okay. And readjust the width so that we can see both all of the colors. There we go. Okay, so we have all 4 blues, for the first one, and then we click check. We got 1 black peg. Okay, so 1 black peg and 0 white pegs. The program is now moving on to 0, 1, 1, 1, which will correspond to blue, green, green, green. Is that okay so far? Does everybody understand how I'm playing the game? Okay. So I have blue, green, green, green. Click check. We have 1 white peg. So we have 0 black pegs and only 1 white peg in this case. And the computer moves on to 2, 0, 1, 1. So far it actually does make sense. Okay, the guess is coming back from my program does make sense. 2 is an orange, so we have orange, blue, orange, and orange. We check. Now we have 3 black pegs, and the computer. So I have to enter the score into the text window here. So we have 3 black pegs and 0 white pegs, and the computer now moves on to 2023, which will correspond to orange, blue, orange, and purple. Did I enter something wrong? No? Okay, that's right. Okay, because there's no actual way to tell which one is the actual color. So now I have to enter 2 and 1 into my program. 2 black pegs and 1 white peg. And the computer moves on to 2042. So that would correspond to 2 is an orange, 0 is a blue, 4 is a red, right? 0, 1, 2, 3, 4, 4 is a red, and then 2 is another orange, like that. Click check, and I got it. Yep. So that's what your program is supposed to do too. Let's do it again. And remember, there's no intelligence behind this particular program. It is really just brute force. It is just brute force generating all the possible patterns, comparing each one to the history of all the guesses that you have done so far, and say, okay, if this is the actual hidden pattern, would it have given me the scores that I have gotten for the past guesses? Does that make any sense? Okay, let's do it again. Let's do it one more time, And if you guys have any questions, so in this case, my program, if I enter 4 and 0 into the program, it says, yay, I got it. Okay? Let's do it again. New game and restart the program. It is always starting with blue, 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 which is not optimal, as I said. So we click check. This time we only got 1 black peg and 0 white pegs. So we move on to 0, 1, 1, 1. Click check. 1 and 1. So we put the 1 and 1 here. Now we have 2, 0, 1, 2. Click check. And we are still having only 1 black peg and 1 white peg. And this time we have 3, 0, 3, 1. So 3, 0, 3, 1. Check. We have 3 black pegs and 0 white pegs. Now we have 3, 0, 4, 1. Check. We have 2 black pegs and 1 white peg. Now we have 5, 0, 3, 1. Click check, and we got it. So are there any questions? Yep, go ahead.
So every time it's trying to formulate a guess,
Yes.
is it just say, hey, I think this could be the pattern, and it puts it into hidden, and then it says, compared to my history, is this a viable guess?
Yes.
And if it's not, then it'll come up with a new pattern, and it'll put it into hidden, and then check it again.
Well, when you're generating, it really doesn't matter whether it is in the hidden of the history. You just need an array of integers to store the pattern that is being tested. But once you know this is a viable option, this pattern does match all the previous guesses, then you have to put it into the hidden member of the history. Now, in my program, I just use the hidden member the whole time, is because there's no need to actually copy it around all the time. But that part depends on how you write your code. So you have the option. The bottom line is when auto guess comes back, hidden should have the pattern, the next guess pattern. Any other questions? Yep, go ahead.
So in our program, do we have to enter the black peg and the white peg when you do it on the screen?
That part is done by main.cpp. So you don't have to deal with that part. In other words, if you look into the homework assignment, okay, maximize this, it will remember the other size, so it's going to be okay. So, nope, don't worry, this is not your homework assignment. But it might be your homework assignment next semester if you're taking cisp 310. No, I'm just kidding. I never reuse the same homework assignment twice. But you can study it. It will still be useful. So we look for arrays. And then we look up the last homework assignment, which is Mastermind Automated. So when you look into this program, I have main already done for you. And for those of you who might have forgotten, let's see here, this is main. There should be an int right here. I forgot to type in the int, so this program will not compile because of that. Okay, that's the only part that is missing. But this is all done here. Okay, so your question was asking, do you have to write the code to ask the number of black pegs and the number of white pegs? Well, if you have read this code, you will know the answer. Because it's prompted right here. Enter the number of red / black pegs, and then enter the number of white pegs. So I strongly encourage you to read the main program first, just to understand how your subroutines are fitting into the grand scheme of things. Because that will also kind of be helpful to kind of understand, okay, I know that AutoGuess is going to be called before I print the actual hidden pattern. Well, that tells you, AutoGuess is the one that has to generate and return a particular pattern. Okay. Are there any questions about the main program itself? How many people have read the main program? And if you have any questions about it, this will be a good time to ask. Because remember, we are canceling the class next Monday. Okay, so the next time we meet will be next Wednesday, which is good in a way. This is kind of a good news, bad news thing, because the good news is we are not meeting in a week. You have more time to work on your homework assignment. The bad thing is I won't be able to answer your questions next Monday. I'll still have office hours, not on Monday, but on all of the other days. Question? Okay. How many people have gotten started with this one and have a general idea of how to get it started? Okay. So the most crucial part of this homework assignment is the recursive subroutine to generate all the possible patterns. And as I have indicated in the previous class, in the lab portion of the class, I think sometime last week, I talked about that code already. So, that would be a good starting point, is to integrate that code into a subroutine that you have to write, but it's not one of the ones that I mentioned here. So you need an additional subroutine. AutoGuess will have to call a recursive subroutine that is not listed here. And you can name that subroutine anything you want. Okay, I named mine, AutoGen for generate, or generate and test if you want to. But you have to, you need an additional subroutine to do the recursive call. Yep.
Are you supposed to define it within the structure of
mmauto is defined here.
But is that where you're supposed to define your extra?
If you need any extra things, you can put it right after or before history. In my implementation, I did not use any extra stuff. So I'm just reusing, I'm just burning processing cycle to retest 0000, which is going to be ruled out. But that's okay, because processing time is really, really inexpensive. Did you guys see any delay when I entered the number of black packs and the number of white packs? I pressed the enter key. Did we have to wait like 2 seconds for the new guest to come up? Well, then there's no need to optimize the program, because we got so much processing power relative to the problem of this particular game. It really does not matter. Okay. Are there any other questions? No other questions?
Well finished, not finished, and well not AutoGuess.
Okay.
So are we gonna return 0 when we're able to generate a guess and return something else?
Yes, it is described here. So the convention that is related to AutoGuess is already described here. So AutoGuess is the one that tries to come up with an actual pattern as the next guess. If you can find an actual new guess, it's supposed to return 0. If for some reason it cannot generate a new pattern that meets all the requirements of all the previous guesses, then you have to return a 1 to indicate, I cannot come up with a new guess anymore because of some inconsistent scoring. Does that answer your question?
Yeah.
Okay. So let me just run the program one time, just to let you know, what happens here. So this one, I'm just going to finish it. Okay, let's go ahead and run this program again. And this time, I'm going to give it some kind of crazy feedback that is not possible. The current guess is 0, 0, 0, 0. So I'll give it 0 black packs and 2 white packs. That should not be possible at all, because I have the same color on all different packs. It should not be possible that one peg is the right color but at the wrong position. Does that make any sense? This whole thing is self-contradictory. There's no way this can happen. So the moment I press the enter key, the computer understands that I probably made a mistake or intentionally tried to trick it. This is the one time that AutoGuess is going to return a non-zero value, because it is not possible to find one pattern that can meet this particular requirement, to having 0 black pegs and to have a score. To have a score of 0 black pegs and 2 white pegs when the guess pattern is 0, 0, 0, 0. All right. Are there any other questions? Do you guys want to see it one more time? How it runs? Okay, one more time? Okay. So this time, when I run it again, just kind of think about, what kind of question you might have when you are writing this code. So this way, we're not just playing the game. We are actually going to use it as an opportunity to answer the questions. No, that's another one. I lost. Oh, there we go. There we go. New game, and let's resize everything back to there. Alrighty. Okay, so I'm going to rerun the program again, and it always starts off with 0, 0, 0, 0, which is blue, 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 blue. Check. So this time we got 0 and 0. The next pattern is green, 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 and press, click check. We have 2 black pegs and 0 white pegs. The next pattern is 1, 1, 2, 2. We have 1 black and 2 whites. So 1 black and 2 whites. And you can see that this particular game engine makes use of black peg to indicate that there's 1 peg in the pattern that is of the right position and the right color. And yet the other game uses red pegs for the same purpose. So that's why it is kind of dependent on the game. This is the game that this is the standard that I grew up with. So the first time I saw the other one go like red pegs, that's why it's kind of it's a little bit it was a little bit confusing to me. Okay, so the next pattern is 1, 2, 1, 3. So this is 1, 2, 1, 3. Check. 3 white pegs and 0. Oops, I just entered something wrong. So this time I think the computer will, yeah, that's not going to work. Let's do it again. 0, 0, 2, 0, 1, 2, and 0, 3. There we go. So the next pattern is 2, 1, 4, 1, 2, whoops, that's 2. That's 2, 1, 4, 1. Check. So we have 3 and 0 this time. 2, 1, 5, 1. 2, 1, 5, 1. This one has got to be right. There's no escape from this one, because at this point the computer has already locked in the first, second, and the fourth position, and with the third position, this is the last color possible, right? So this has to be the pattern. Click check, and we got it. I think with only 6 colors, it can always be solved within like 7 steps. And if you use the optimal test pattern, I think somebody proved that it can be done always in 6 steps or less. But since we are allowed up to 8 steps, using the default in mmgame.h, it should always be solvable. Are there any other questions about how this program is supposed to work? No questions? I am going to put a link of this particular URL onto Moodle. Just for those of you who want to use exactly the same game engine for testing purposes, we can have it too. So getting back to website. Oh, have to turn on editing. And insert a URL. That's it. Let me just ask, how many people actually did the pattern generating logic? Nobody? Okay. So you can now generate all the patterns from 0, 0, 0, 0 all the way up to 5, 5, 5, 5, right?
I didn't write it, but I wrote it down.
Okay. Well, you have to do it recursively, because when if I change the number of positions in the pattern, then the recursive way is the only way to get it done. Yep. All right. Any other questions? No other questions. Well, if you guys think of anything to ask about this one, let me know. And then meanwhile, we're going to go back to cover some of the topics that I said, well, we'll talk about this later. Later is today. Today is a good time to talk about those things. The one thing that your other professor will assume that you know already is not any one of the control structure stuff. It is going to be the input-output. So within input-output, we talked about how to use printf, scanf, throughout the whole semester. Those are what we call, just regular C functions. There's another way to do it. The other way to do it is, described in an alternative C++ hello program. So we'll take a look at this one here, just to find out, what it is. I'm just going to close all the other tabs that we don't need because it's just using a lot of space on in the browser. There we go. So the alternative way to use what we call C in and C out. Okay. So the description, starting here, basically says streams are used as an abstraction of files. Scanf and printf are subroutines. They are not streams. They are basically subroutines that are used by a lot of regular C programs to interact with standard input file and a standard output file. When you are moving on to cisp360, which is called object-oriented programming, your professor will try to emphasize to do things in a slightly different way. You will be using objects. Okay, so you'll be using objects to get things done, and that's why we have to describe this different way of doing it without using printf. The best way to do this is to describe the actual program first, and then we'll talk about what is cout and what is the other features of this particular program. This is the Hello World program, but it is using the object-oriented way of doing things. Functionally speaking, it is the same as the usual Hello World program using printf, but from the design perspective, it is different. So we'll take a look at this particular program line by line and try to identify the differences between this one and the usual printf program. The first thing you might notice is the pound include is different. Instead of pound including stdio.h, which is a header file, we are now pound including IO stream with no file extension. Okay, this is the standard to include the header file that has all the necessary definitions of the things that we'll be using in this particular program. The second thing is something that we have not seen before. This is a statement that we have not seen before, using namespace standard. Okay, STD is an abbreviation of standard in C++ programming. It's basically a shorthand. Okay, this allows you to write programs without having to say STD : all the time. Okay. The next line we have seen already. This is no different from the other Hello World program. It is just the main function itself. And then on line 7, we are seeing something new again. Cout is an object. Okay, cout is not a subroutine. Unlike printf, it is not a subroutine. It is an actual object. An object is kind of like all variables are objects. Okay. But when you move on to cisp400, there'll be other types of objects as well. But at this point, we just have to understand that cout is a IO stream object. It is a variable. It is a global variable, which is defined somewhere else, but you can use it. Okay. This particular thing, the less than operator, is also known as. Okay, which way are we shifting if this is done to an integer? I'm hoping you guys still remember the shift operators. This is a left shift operator. Very good. Okay, so this is the left shift operator. But when you apply the left shift operator on a IO stream object, it means something that is completely different. What it means in this case is we want to print this particular string, hello world, to cout, which is representing a file, which is representing the standard output file. Are we still doing okay so far with this code? This entire expression, okay, the highlighted portion on the projector, this is one expression, and every expression has a value. This expression has the same value as the first operand or cout itself. So that means when we try to apply the second less than or the left shift operator, this is also done to cout because the first expression is just returning cout. ENDL is the abbreviation of end line, which is the same thing as a \n, which just means, you know, okay, I'm ending this current line and start the next line at this point. Are we kind of doing okay so far with this code? Yes? No? Okay. Let's go ahead and write the program, and I'll illustrate a few points when we actually get to write this program. So I'll finish this one first. And I'll just make a new folder called cout and put all the code here. So main.cpp, pound include. Well, let's try to make all kinds of mistakes, you know, just to see what the compiler will complain, how the compiler is going to complain when we make these mistakes. So I'm just going to write the main subroutine and say cout hello world and semicolon and return 0. In other words, I'm doing a very sloppy job of copying the actual program. And then we want to find out what the compiler is going to complain about this. So we say G++ -1 all -o main.cpp, and it complains about, hey, cout is not declared. Well, that is not really surprising because cout, remember, is supposed to be the name of a variable. Well, I'm not defining that variable. Somebody has to define that variable. Somebody has to declare and say, hey, this is cout, it is blah, 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 blah. That is the job of the pound include. Okay, pound include IOStream will basically include the declaration of cout so that I can use it. Okay, fine, that's an easy way to fix it. Pound include IOStream, which is the name of a header file. We compile the program. Oh, okay, this time it complains again. But this time the message is really kind of confusing because it says cout was not declared in this scope. Well, it's a little bit different from before, okay, because before, well, it complains about the same thing, but this time it has a suggested alternative. In other words, GCC is being kind of smart and say, maybe you meant std : cout. That's because cout as a variable, as a global variable, is defined within a certain what we call namespace. Now, the necessity of a namespace has to do with when people write subroutines, sometimes they choose to use the same name as the subroutines. I'll give you a few examples where, you know, it is common to have those, you know, particular names for subroutines. Max to find the maximum, min to find the minimum. There are quite a few names that are used in many different contexts, but the subroutines have all the same name. So namespace is a way in C++ so that you can define a particular namespace so that different namespaces can contain definitions of exactly the same name. Are we doing okay so far with this? It's kind of, the concept of a namespace is not unsimilar to the concept of a family name or surname or last name in the United States. Okay? This class may not have this problem, but I have many other classes where I have two Nicholas or Nicholases, right? So if I just say, okay, this is the exam for Nicholas, or if my grade sheet only has the first name, Nicholas, I would not be able to differentiate, is this Nicholas J or is it Nicholas K? Okay? Is that making any sense? So from that perspective, the name of a subroutine is really like a first name. Eventually, you will use the same name again, but in a slightly different context. So if we have multiple subroutines of exactly the same name, how can we differentiate those names? We cannot. The whole concept of a namespace is kind of like a family name. In other words, you can define a whole bunch of subroutines within the namespace, so they all end up with the same last name, quote unquote last name. In this case, std is the last name of this entire family of things that we're defining. So that means, now I can go back to the code here and qualify std : with cout. That will fix the problem. Because now I'm saying I'm not only referring to the global variable cout, I'm referring to the global variable cout with a last name of std. So it belongs to that particular namespace. Is that okay so far? Okay. All right, so let's go ahead and try to recompile this program. And this time it does recompile without any problem, but when I run the program, you can see how hello world exclamation point is not using a new line to separate itself from the command prompt itself. That doesn't look very good. Okay, so what we want to do is to fix this problem. So when we fix this problem, there are two ways to fix it. The first way to fix it is to do it the same way as we usually do it. Well, there's one problem with this approach. This approach is not exactly cross-platform compatible. Now, how is this not cross-platform compatible? It has to do with in a text file, how we represent the end of a line depends on which operating system you're using. Of the 3 operating systems that I know of, okay, they're all different. In Linux, to separate one line from the next, you just need a line feed character, which is ASCII number 10. In a DOS machine, which is Windows, you need both the carriage return and the line feed to mark the end of a line. For those of you who use a Mac, can you guys tell me how you separate one line from the next? Okay, it is a single carriage return, ASCII code 13. So you can see that all of these operating systems have a slightly different way to end a line. Doing it this way is not very portable because it means \n technically only means ASCII code 10. So this will only work in Linux. It will not work in DOS. If you want to do this in DOS or Windows, you will have to change \n to \r\n to mean we have a carriage return followed by a line feed character. If you want to use a Mac, you only need a carriage return at the end. Well, that's kind of cumbersome. I mean, I have to be aware of which platform this program is intended for in order to decide how to end a string. So that's why in C++, they also have endl as a global variable. And this one depends on which platform it is running on. If you run this on a Windows machine, it automatically maps it to a carriage return and the line feed. If you run this program on a Linux box, it will automatically map it to just a line feed character. If you run this on a Mac, it will automatically map it to just a carriage return. So from the programmer's perspective, this is a lot cleaner because I don't have to worry about, hey, which platform is this program intended for, and make that decision accordingly. So we'll go ahead and try to recompile this program. It's going to have a problem. Oops, recompile first. And it has a problem because end line turns out to be the same thing as cout. In other words, we cannot just say end line. We actually have to say std : end line because it is a name. End line is just a first name, but we have to combine it with the last name. So now we have to go back to the program and make that really kind of tedious change and say std : end line, and this will fix the problem. So we'll go ahead and do recompile, not a problem. Run the program, not a problem. It behaves exactly the way we expected. But that means every single time you use anything in IOStream, you have to basically use a prefix of std : which is a lot of typing. Okay. So if you think that you won't run into a problem of duplicate names, there's a way to fix this problem, or it's not exactly a problem, but make it a little bit easier to type a program. So you can basically say using namespace std : line 3 is basically saying if I do not specify the last name, we can use this as a default last name. So this way, when I refer to cout, I do not need std::: anymore, because if cout is not found to be in my own namespace, it will automatically go to the default namespace of std, it will find a match, and there won't be any problem. So it really is a convenience feature, but it somewhat defeats the whole purpose of a namespace in an object-oriented programming language. So I have kind of mixed feeling about line 3 here. On one hand, it saves you some typing, at least for beginning programmers, it makes programming in C++ less frustrating. But on the other hand, it is also defeating the whole idea, the whole purpose of having namespaces. Yep.
So can you use a different namespace with like a separate prefix? Or
You can
same?
use different namespaces at the same time. In that case, what would happen is the first using namespace would have the top priority. So we'll try to assume, okay, since you did not tell me what the last name is, I will try to match it with std first. And then if you have another using namespace below that, that will have the second priority, and so on. But it still kind of works against the whole idea of having namespace to begin with, because this way you will still end up with a name collision at some point, and it means why have namespace to begin with if all we're going to do is to have using namespace to shortcut the whole thing. Okay. And for those of you who are kind of more curious about what a namespace is, you can just click use a search engine and look for C++ namespace. And the first link that comes up, will fully explain, why we have namespaces. It has to do with how do you control the visibility of names. So I will leave it up to you to read this part here if you want to. It is optional because it's not really exactly a important concept as far as coding is concerned. It is an important concept when your projects or when your programs get larger and larger, because you will have to start to manage the actual names of your variables and subroutines. Okay? For small programs, it's not a big deal. There's also the question of why isn't there a extension of .o with after IO stream? Well, I found this particular link here. It is a long history, but it has nothing to do with actual programming concept. It really has to do with it's more of a philosophical kind of thing than actual programming concept. So I will leave it up to you to read the long history of why there's not .h. There's no .h after IO stream. There was one time that there was a .h, and then they took it out. Okay, and you can read about the history. Are there any questions at this point about this program? No questions? Okay. So basically, we have gone through all of these explanations here. The same thing about redirection will work because cout is really just representing standard output file, and all of the things that we can do on the command line will still work. This one talks about how to print a value. We have already talked about how to print a value using printf. In other words, we have kind of talked about how to use what we call a format string within printf in order to specify, hey, this is just a placeholder. It is supposed to be an integer. This is also another placeholder is supposed to be an integer. So in this case, we have two placeholders. This is the first placeholder. It is a placeholder to print an integer. But when you print an integer, you have to specify a little bit more. In this case, it is printing an integer as a signed integer in base 10. So it will be a decimal number that we can easily read. %x is also a placeholder, but this time it is a placeholder to print an integer in hexadecimal. Okay, so the same integer will come out slightly differently depending on the format string. This is how we do things in C, regular C, which you can also use in C++ programs. The other way to do this, which to many people is quote-unquote the easier way, is simply to use cout. If you want to print an integer using cout, this is all you have to do. There's no format string to specify. You simply have to say cout less than, which is also called the left shift operator, I. And I is an integer. That's it. That's because this is type sensitive. In other words, the left shift operator will try to look at the type of whatever is on this right hand side, and depending on the type of the thing on the right hand side, cout, which is the IO stream object, will automatically know what to do to print it out. So there's no need to specify a format string when you're dealing with cout. What if you want to print it in hexadecimal? Well, this is what you need to do when you want to print it out in hexadecimal. In this particular case, hex, H-E-X, is not the name of a variable of yours. Okay? Instead, it is a flag to tell cout to say, from here on, switch to print everything in hexadecimal. That's basically what it means. Are we doing okay so far with these concepts? Okay. But the problem with hex is it would switch the mode of printing integers from here on. It is not only limited to this particular statement, all future statements will also use hexadecimal to print integers. So this is a major difference compared to using printf. Because printf, the format string of printf, which is here, only has effect to a particular placeholder. In other words, this placeholder called %x is the only place where something is specified to print in hexadecimal. It will not affect anything else, because every time we specify a placeholder, we also have to specify how are we printing this particular integer. So there's no what we call persistent effect when you're using printf in the format string. When you're using cout, on the other hand, the effect is quote unquote sticky, right? Because after you switch to hex mode, it will print all integers from here on in hexadecimal instead of in the regular decimal representation. So that means, if you want to keep switching between base 10 and base 16, this is what you need to do. You basically have to make sure before you specify a value to print, you have to make sure that it is now specified in base 10. So this particular part, I'll just go ahead and highlight the part that is important here. This particular part basically says switch to print in, numbers in base 10 and then go ahead and print the value of I. But from here on, it is sticky. From here on, all integers will be printed in decimal. So that means if you want to switch back into hexadecimal or print it in base 16, you have to specify, from here on, switch back to hexadecimal. So I'm not really sure whether this is actually easier than the other method, because it's just different. Okay, from my perspective, it is just different, not necessarily better. Are there any questions about using cout? No questions? This is all good? Okay. Moving on to mixing and matching. It is not a good idea to mix and match the use of printf and the use of cout. These two things, they probably won't cause you any actual trouble, but that part depends on the implementation. In other words, just because it doesn't give you any problem when you're using GCC or G++, does not mean that it will work properly in other environments. So as a rule of thumb, you do not mix printf and cout together. Which you can also interpret as you never #include stdio.h and #include iostream in the same program. You do not want to mix and match those two. Are there any questions about this particular document? No questions? What is your opinion? Do you think cout is easier than printf? In a way it is, in a way it's not. It's just different. But I have to talk about cout because your professor in CISP 400 will probably assume that you know how to use cout instead of printf. Okay. So if we're all done with this one, we move on to the next one. How do you get something from the standard input file? Well, we talked about this already, okay, using scanf. In fact, we have used scanf quite a bit. in this class. So we don't really have to go through this part because it doesn't really talk about how to do it the other way using cin. So we're going to move on to the other one. So I'm going to skip to this one and then go back to error checking. Okay. So using cin instead of scanf. We know how to use scanf already. Now this time it is a little bit easier because there's the first thing is there is no need to use a format string. So depending on the type of X, cin right shift X will automatically use the proper interpretation of the standard input file in order to read something into a particular variable. In this case, if X is an integer, it will automatically assume that we are reading the integer into variable X, and it's going to be in decimal. Is that okay so far? Well, that seems to be pretty easy. And also the other thing is when you look at the way we do it using cin, okay, remember in scanf, we have to introduce a new concept just because we have to talk about scanf. Which new concept did we talk about?
Pointers.
Pointers, or the address of the ampersand operator. In this case, this is not a typo. I did not forget to specify an ampersand. You actually do not need the ampersand in this case. That's because when you're using when you're using scanf, it is actually expecting the address of an integer. And you have to use the ampersand operator to extract the address of an integer. In this particular case, it is called pass by reference. In other words, you just have to specify X. The compiler will automatically understand and say, oh, cin does not need just the value of X. It actually needs the address of X. And it's all handled, like quote unquote under the table, so you don't get to see all the dirty details. So that's why many people prefer it this way, because you don't have to specify the address of. In fact, if you specify the address of, it will complain and say, hey, you're not supposed to give me the address of an integer. You're supposed to give me just an integer. Are we still doing okay so far with this concept? Passing by reference saves you, the programmer, the trouble of having to use the ampersand operator to get the address of something. Is that okay so far? Kind of? Example? This is the example, because in the C++ code, we'll have to specify scanf, and then we have to specify address of X instead of just X. But when you do it in C++ using cin, you only have to specify the variable itself. You don't have to say the address of the variable. Okay. All right, so we got most of the stuff done, except what about error checking? Remember all the error checking stuff that we did earlier? Okay. So we go back to error checking and handling. Using scanf, it's not too bad. Because what happens is, when you use scanf, it has a return value to tell you what went wrong. If anything went wrong, the return value will tell you what went wrong. Okay. Just to refresh your memory, we're going to look at the man page of scanf. And for that, I'm going to have to maximize the screen area. All right, this is the man page of scanf, which I hope some of you, if not most of you, know how to get to at this point, because the man pages is a really useful resource when you are writing programs. So in this case, we will go kind of skip all the way to the return value part. So we'll skip all the way to return value. And in this case, you can see that these functions return the number of input items successfully matched and assigned, which can be fewer than what is asked, what is requested, even 0 in the event of nothing matches what you're asking for. Okay, we know this part already because we have used this kind of code in many of the programs that we have written so far. The value EOF is returned if the end of input is reached before either the first successful conversion or a matching failure occurs. EOF is also returned if a read error occurs, blah, 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 blah. Okay, but the bottom line is if scanf encounters any problem, the return value will indicate, hey, we got a problem here, okay? I was asked to read an integer and I did not see an integer, okay? I was asked to read something and I encountered in a file, okay? I could not read anything. So the return value is really valuable because it tells you that, okay, something went wrong and this is what went wrong, okay? What about cin? Well, cin works in a different way. So when you're working with cin, okay, and it is not successful, then it is somewhat of an awkward way to tell whether it was successful or not. So we'll take a look at this little chunk of code here. Int I, okay, I don't think we need to explain this one. You know, I is a local variable of the integer type. This line, I don't think we have to explain it too much either, because what it means is I am going to read something from standard input file, interpret it as a, by default it is going to be a base 10 number, interpret the base 10 number into an integer, and store the value of the integer into variable I. That's what cin, right shift to I, means. That's easy. What if the standard input file does not actually contain an integer? Instead, it contains some gibberish. Well, with scanf, it just returns 0 and say, hey, you asked me to read a base 10 number. There is none in the input file. I'm stopping. I'm reporting that I did not read a single thing. That's pretty easy to deal with. In this case, it's a little bit more awkward in a way, but it is object-oriented, so some people like it better this way. So now we look at this construct here and go like, whoa, that's not a Boolean. Cin is a input is representing a file. It is what we call a stream, an input stream. It is not a Boolean. How can we put something that is not a Boolean in place of some place where a Boolean is expected, something that is either true or false, or at least an integer is expected? Cin is not an integer either. Okay, so what is going on here? Is this code even going to work? Well, it is going to work because cin, the way this line works, is the compiler is smart. The compiler says, within this context, I'm expecting a Boolean. But what is given is not a Boolean. So what the compiler is trying to figure out is there a way to convert this thing, which is an input stream, into a Boolean? And there is a way. And that's why the compiler knows how to convert cin, which is an input stream, into a Boolean type, using what we call one of the methods of cin as an object. During that conversion, what it really is doing is to see if the previous read was successful or not. If the previous read was successful, cin as by itself will automatically be typecasted by the compiler to true. And therefore, we go to the then branch. On the other hand, if the input stream does not contain a base 10 number, then cin typecasted into a Boolean will be false. As a result, we'll go to the else branch, and you can do some error recovery or handling type of logic. Are we kind of doing okay so far with this code or not? Well, let's write a program to test it, okay? Because that's the easy thing to do, right? Whenever you study for a class like a programming class and you encounter a concept, the best way to do it is to write a simple program to test the concept. Just because when you do that, you're doing three things all at the same time. One, you're getting more familiar with the programming tools, okay, which can only be useful. The second thing is you are exercising your mind and say, okay, did I interpret that particular paragraph correctly? That is studying. And the third thing is you're verifying the concept is in fact true or not. So you're doing all three things at the same time when you write a sample program to test something that is described in text. Okay, I'm just telling you, if I were to take another programming class, I don't know enough about Python. I might take a Python class. That is how I would study. I would read something in the textbook, and I would type up some script to test whether that concept is actually as described in the textbook or not. which most likely really is the case, but I would get a confirmation by actually interacting with the computer to confirm that concept, because it's hands-on. I can understand concepts a lot more readily when I'm doing something and go like, oh, okay, I can see this is how it works. Okay. All right, so we'll go ahead and use that approach here. So I'm going to say error checking.cpp. I'll include IO stream, and I am not going to use using namespace std just so that you can see what it looks like, what the program looks like without using namespace. Okay, int I, just like with the other one. So I'm going to say cin into I. If cin without anything, if it is true, I'm going to still do a cout here. Okay, I read an integer of value I without issues, and line. And some of you can tell right away, hey, Tack, this is not going to compile because I'm missing all the std : colons, right? I'll fix that later in one single shot. And then in this case, cout a base 10 number was not read. Okay. In the L, if I were to compile this program the way it is right now, I will get a lot of errors and a lot of recommendations, because the compiler is smart and say, hey, there is cout, cin, and end line, but they require the use of a namespace specifier. Okay, so I'm just going to do it once so that you can see what kind of error message you will get when you do something like this. Error check.cpp. And this is what you get. Okay, a whole bunch of errors, but you also have suggested alternatives. Basically, the compiler is telling you, hey, you might want to fix this problem by using std : before cout, cin, and end line. Okay. So if I were to fix the program without using namespace, I would have to replace all those things. So I'm going to have to change all the couts to std : cout. I will have to change all the cins, same way. And also end line is the same way. Okay, so I'm going to change all the end line to standard end line. All right, so now the program is all fixed. So this is definitely, I would consider this a subjective thing. Is it worth the time to type up all the std : or do you want to using namespace, and therefore kind of invalidating the whole concept of using namespaces to begin with? That's something that you have to decide for yourself. Okay, but you can use either approach, either spell out std : all the time, or using namespace std just at the beginning of the program, so you don't have to type all the std : Okay. Are there any questions about the logic of this program, or or about what I am trying to test here? No questions? Okay. Then no questions. We'll go ahead and compile the program, and we'll first give it an actual integer, okay, so that we know that it will go to the right branch. 45, okay, not a problem. It says, I read an integer of value 45 without issues. I forgot to put a space before without, and that's why 45 and without are kind of, right next to each other. I will run the program again, but this time I'll give it a non-integer, okay? In fact, I can give it A45, because in this case, it will try to interpret A as a part of an integer, which will fail, and then it will not even try to go past that point. Press the Enter key, and it says a base 10 number was not read. So this is kind of the same thing as checking the return value of scanf to see if I actually read the item that I requested. Okay, but there's one major difference in this case. The one major difference in this case is I cannot just clear a character after this, because cin is it remembers. Okay, cin is an object. It is a global variable. it actually remembers whether the previous read attempt was successful or not. If the previous read attempt was not successful, you cannot read any further. Unlike scanf, where it just tells you, hey, you asked me to read an integer, it was not successful. But the next time you say, okay, this time, see if you can read just a character. Not a problem, I can read a character. So it does not remember that the previous scanf was a failure and therefore stop any further attempt to read anything. cin does that. Okay, so cin would actually remember, oh, last time you asked me to read something, it was not successful. I am not going to let you read anything from here on. That is the logic of cin, until you say it is okay. So it's not like permanently banning you from reading anything further. It's just that you have to call the clear function first. Okay. So this is also a new kind of a new syntax. It's a combination of things that we already know and things that we have not seen yet. Okay. We have seen something like this. Now, if you just kind of cover up the cin part, we have seen something like this with open and close paren. This is how you call a subroutine. Okay. When you call a subroutine, you basically specify the name of the subroutine, and then you use open and close paren to say that, okay, this is a subroutine. We have also seen something like this without the parentheses. We have seen the name of something, a dot, and then something else. This is how you access a member of a structure. Is that okay so far? The concept of calling a subroutine, you should get it by now. The concept of accessing a member of a structure, we should also get it by now. We're now combining those two. In other words, the subroutine is actually a member of the variable. Now, in this class, we're not going to talk about it much. Okay? In the next class, which is cisp360, you will learn more about object-oriented programming. This is something that you cannot do in regular C, but you can do it in C++, which is an object-oriented programming language. You can define what we call methods inside a quote-unquote structure, which we call class in the next in cisp400. Are we kind of doing this part okay or not? So for now, we just say that there are functions that we can call that are quote-unquote members of objects. So once we call clear, then we can actually go ahead and say, okay, here is junk, which is our character, and then you can just read something into junk, which clears away the one character that is at least a part of the problem of reading an integer. Then you can reattempt to read an integer. So the logic to do error detection and handling is a little bit different compared to scanf, because you have to remember to call clear before you try to clear away the junk that can be potentially before an actual integer. Yep.
You said character, but that says integer.
Yeah, because an 8-bit integer is a character. Or I should say the other way around, a character is just basically an 8-bit integer. So the name, so when I use int8_t, it really is the same thing as a char. All right. And then the other thing you can also notice is when we read into a character, there's no double quote %c double quote, because remember, in cin, it does not need a format string. It does not make use of a format string. Instead, it uses the type of junk to imply what to do to read into it. So when junk is a char, cin understands, oh, I'm supposed to read just a byte from the input file. As opposed to when I is a 32-bit integer, it knows that it has to interpret an integer in base 10 out of the input file, or the standard input file. So frankly, I do not know whether this is actually easier than scanf. I think it is just different. It is definitely object-oriented, but I think it's not much better or worse than using scanf. It really boils down to which one you're more used to. Are there any questions so far about using cin and cout instead of using scanf and printf? No questions? How many people want to redo all the previous homework assignments instead of using printf and scanf, change them all to use cin and cout? No, not even if it is an extra credit homework assignment.
Well, in the middle of the semester, yes, but like 1 or 2 more weeks and it's final, so.
I'm just kind of kidding. Yep. Alrighty, so now we can say something like this. You can actually combine the attempt to read something and also checking it at the same time. Now this one looks really confusing, right? Well, let's take a look at this operation here. So what I'm going to do is I will write the expression using a tree format. Okay. So we have the operator, we have cin, and then we have I. Okay, we are focusing on the condition of the conditional statement. Okay, this is what we can see at least. Cin is a IO stream, and this is the right shift operator. Now, when you have the right shift operator working on an input stream, it specifies a particular type of operation. Typically, the quote-unquote side effect of this expression is it will try to interpret bytes coming in from the standard input file, and it will store the value represented by those bytes into I. That's the side effect. But every expression returns something, has a value. What is the value of this particular expression? We talked about this earlier when we talked about cout. So what is the value of this expression? The value of this expression is cin itself. Okay. So when this is all done, it will say, okay, the value of this expression is cin. Now it might have done something with I, but the value of this expression is just cin itself. In the context of a conditional statement, it is expecting something that is Boolean. In other words, the compiler is saying, I want a Boolean. But the expression says, I can give you a cin. So the compiler will automatically search for a way to do that conversion. In other words, the compiler does understand there's a mismatch between the actual value of the expression and what is expected in this context. So it is actively trying to look for a way to convert a cin, which is an input stream object, into a Boolean value. This is where things get kind of interesting, because when you look up cin, in input stream methods. In the next class in CISP 400, this website may be your best friend. It's called c++.com, and guess what it does? Talks about the C++ standard, right? So now we look into, this is called what we call an inheritance hierarchy. And let me see if I can find the one that I'm looking for here. There we go. This is operator bool, which is a typecasting operation. And if I just magnify the text here, evaluate stream. An input stream is a stream. It returns whether an error flag is set or not. In other words, it's basically saying, did I encounter problems? So that is the missing link here. I have a cin type, okay, or a stream type with this expression, but the compiler is saying I need a Boolean. And the compiler can automatically search through all the different ways to convert a stream into something else, and it will say, can I convert this into a bool? Can I convert it into a Boolean? Yep, there is such an operation. And as a result, it will pick that operation, and as a result, the Boolean value of the code that I just wrote is going to reflect whether cin got into any problem before or not. Is that okay so far? Kind of? There's a lot of hidden operation, with C++ programs. And that's one thing that you have to be kind of aware of, when you program in C++, is a lot of times things are not what they seem to be. Okay, a lot of hidden stuff can be happening. So if I go back to the program that we were talking about here, so this is actually combining, let's see, 1, 2, 3. There are 3 things that are happening with this one single expression. The first thing that happens is it will try to read the input, the bytes in standard input file, as a base 10 integer by default and store that into the variable I. That's the first thing it does. Second thing is the expression will have its own value. The expression has a value of cin. That's the second thing it will do. The third thing is it will try to convert a string object, which is not a Boolean, into a Boolean value, which is either true or false. That conversion process is basically just reflecting whether the read operation or any of the previous read operation encountered an error condition. So as a result, this is the right context. This is the right use of cin right shift into I, because I am just performing the read operation and getting a status of the read operation. Was it successful at the same time? If it was successful, it returns a true value, and then I can just go to the then portion of the conditional statement with the assumption, which is going to be valid, that I actually read something into variable I. On the other hand, if it is false, it means the read operation has a problem. Okay, I did not actually read an integer for a variety of reasons. But then I can go to the else branch to further figure out, okay, exactly what went wrong. Did I encounter any file before I have a chance to read anything? Or is it really just that the content of the input file does not match a base 10 number? I can figure that out in the else branch. Are there any questions about this particular expression?
So if we wanted to recover, we just have cin jump in the else range?
Not just that, you have to do a cin clear first. Because remember, cin is a variable. It actually remembers whether the previous read operation was successful or not. If you have a failure to read something, it is sticky, and it will stop it from any further reading, so that you can check what went wrong. And then until you say cin.clear and then parentheses, it won't let you read any further.
So clear, it's not actually, because when you first said clear, I thought it was clearing the variable, but what it does is just clearing that memory.
It's clearing the error status. It's the same thing as resetting the engine check light. But in this case, in this case, if for whatever reason your engine control unit think there's something wrong with emission control, it would actually stop your car in the middle of the highway and say, I'm not going to start until you plug in something into the onboard diagnostic 2 connector to clear the check engine flag. It won't let you even start the car again to drive to begin. Is that okay? Do you guys understand the concept? Okay. Are there any questions about this code? No particular questions? All right. Well, in that case, it is just in time. Okay, we finished this topic just in time. We're canceling the class on Monday, so do not come here. Well, you can come here if you want to, but I won't be here. I will actually be stuck in a interview marathon, going from 8 a.m. to 5 p.m. There are 7 candidates, and each candidate will take about an hour, because there's a written part of the interview, there's a teaching demonstration part of the interview, and then the actual interview itself, and then time for the interviewers to evaluate and write down actual notes. So so that's what I'll be doing on next Monday. Just in case you guys think, hey, Tech is canceling the class so we can enjoy, the nice weather and whatnot. No, I'll be stuck in a conference room doing that sort of thing. And And I'll leave it up to you to imagine, would Tech prefer teaching in a classroom, or would he prefer to be an interviewer stuck in a conference room interviewing your interviewees? I'll leave it up to you guys to think about that question. And it won't be in the final exam either. All right, so I'm gonna stop the recorder and I'll let you guys work on the homework assignment. If you have any questions about the homework assignment, this would be a good time to ask.